I'm Professor Rad, and this is Precalc video 219, Introduction to Solving Exponential Equations. In this video, we're going to look at a very introductory type of exponential equation and use one tool for solving. However, this tool that we're going to use can't be used to solve every exponential equation, so we're going to be kind of on a quest to develop new tools to solve those equations. So let's just dig right into these equations here. So we have a fact to start us out to help us solve our equations. And it says if you have a to the u and it's equal to a to the v, then the exponents u and v have to be equal. In other words, if you have an expression where you have the same base on either side, whatever the exponents are have to be equal to each other. So that's what we're going to use to help us solve those equations. So let's work through a couple of examples. Our goal in these examples is to get something that looks like this, something that has a base to a power equal to the same base to a power. So for this problem, to begin with, I notice that I'm multiplying by 4, and then I have my exponential expression. So what I want to do is I want to isolate that exponential expression piece, just like we would ordinarily isolate a variable. So I'm going to divide both sides by 4 to accomplish that. This will give me 3 to the x plus 5 power is equal to 9, since 36 over 4 is 9. So that's our first move. Our second move is to get it in the form of exponential expression equals exponential expression, preferably with the same base. So in this case, the base on the left is 3. So can we write 9 as a power of 3? Yeah, we can. 9 is the same as 3 squared. So that's going to be our next move. We have 3 to the x plus 5 is going to equal 3 squared. Now you might be wondering, well, what if, Professor Rad, we had like a 7 here instead of a 9, where 7 is not a power of 3? That's where this method would break down. So that's where we would need a new tool that we're going to work to develop. So right now, for the problems that we'll see in this video at the beginning, we're going to have things that we can write with the same base. Now that these are both 3 to a power equals 3 to a power, we're in this situation, so the powers have to be equal. So this means that x plus 5 has to equal 2. Now we've gotten rid of the exponential challenge, and we have a nice linear equation. So we can subtract 5 from both sides and get that x is -3. There we go. And you can check this equation just like you can check any equation by substituting the solution back into the original problem. So if I were to do that, I'd have 4 times 3 to the -3 plus 5. Does that equal 36? Well, 5 minus 3 is 2, 3 squared is 9, and 9 times 4 is indeed 36. So it checks out, our answer works. All right, let's take a look at this other example. So over here, we have 25 and 125, each of those being raised to a power. So we're in a good shape here because we have an exponential expression equal to an exponential expression. However, they're not the same base. So we have a base of 25 here, and we have a base of 125 here. So we can't just drop down and say x minus 2 is x minus 1. Instead, we have to work to find a common base. In this case, 25 is the same as 5 squared, and 125 is the same as 5 cubed. So we can rewrite these two bases by writing it as a power of 5. So that's what I'll do. So 25 is the same as 5 squared, and that's being raised to the x minus 2 power. Similarly, 125 is the same as 5 cubed, and that's being raised to the x minus 1 power. Now, we're still not in a place where we can apply the fact yet, because I have 5 squared as my base, and here I have 5 cubed. But this is where those laws of exponents come in handy. So we had a law that said if you have a power raised to a power, you can multiply those powers together. So this is going to be the same as 5 to the 2 times x minus 2. And over here, this will be the same as 5 to the 3 times x minus 1. So when you have a power to a power, you can multiply the powers. Now each side has the same base, so we can just set the two exponents equal to each other. So 2 times x minus 2 is equal to 3 times x minus 1. Once again, we have a nice linear equation now to solve, so we can distribute the 2 on the left, the 3 on the right, and solve like usual. So we get 2x minus 4 is 3x minus 3. I'll subtract 2x to bring it to the right, and that will give me just an x. And I'll add 3 to the left and to the right, and that'll give me a negative 1. Same thing, we can check our solution by substituting into the original. So we could say 25 to the negative 1 minus 2 power. Does that equal 125 to the negative 1 minus 1? So is 25 to the negative 3 equal to 125 to the negative 2? And then for this one, I'm going to throw that on a calculator to check. So 25, oh my goodness, my calculator is wigging out. All right, 25 to the negative 3 is going to give me 1, 2, 3, 4. So 0.1234 zeros and a 64. And if I do 125 to the negative 2, it gives me the same thing. So we are good to go. Okay, now being able to write a value with a particular base is going to be a helpful skill for us in solving these equations. So let's look at another example that's not quite solving an equation, but it has that same idea of being able to manipulate the base of the exponential expression to get something that we want. In this problem, we're told that 2 to the x is equal to 3. So in this case, I can't solve for x with the tools that we have at the moment because 3 is not a power of 2, or at least not a nice one that we can know. So we know that 2 to the x is 3. We want to be able to figure out 4 to the negative x. So here's how we can figure out what 4 to the negative x is going to be. Our goal, because we know what 2 to the x is equal to, our goal is to see if we can rewrite this expression so that it has like a 2 to the x to some power. If we can do that, then we'll be able to replace the 2 to the x in that expression with a 3. So here's how we start out. 4 to the negative x equals. Now the good news is I happen to know that 4 is the same as 2 squared, right? So I can rewrite 4 as 2 squared. So I get 2 squared to the negative x. This is good because now I've gone from an expression that has a base of 4 into an expression that has a base of 2, and that matches what we're given here. I have 2 squared. I don't have 2 to the x yet, but we're on our way there. Now, as we did in the last example, we're going to multiply the two exponents to write this as 2 to the negative 2x. That's going to simplify the expression a little bit and make it easier for us to manipulate the pieces. Now, our goal in all of this is to get an expression of 2 to the x power. So we're basically going to take that property we just used and use it again in the other way. What I mean by that is we have negative 2 times x. So I can write this as 2 to the x raised to the negative 2 power. Because if I were to multiply these exponents, I would get back up here. So that's the key for this problem. That's how we end up getting 2 to the x, which is our key that we know is equal to 3. So because 2 to the x is equal to 3, I can replace this 2 to the x with just a 3 and bring down that minus 2. And now it's just a matter of simplifying this expression. So because we have a negative exponent, I can write this as 1 over 3 squared, and 3 squared is 9. So we end up getting that 4 to the negative x is equal to 1/9. And notice in this whole process, we still don't know what x is equal to, but we do know what 2 to the x is equal to. So we were able to find 4 to the negative x without ever having to solve for x. Kind of neat. All right, that's going to conclude this video on solving introductory equations with exponents. In our next video, we're going to talk about a very specific, special type of exponential function called the natural exponential function. So looking forward to seeing you then. In the meantime, I hope you found this video helpful, and I hope you have a wonderful day. Bye for now.